Hi everyone, we are going to do a little bit of review over simplifying square roots or radicals. Okay, so for today, let's just talk a little bit about perfect squares and then how to simplify. Okay, so these are just some rules to follow. First of all, the radicand, which is the inside of the square root, or what's inside the house, it cannot have a factor that is a perfect square other than 1. Right? So anything inside of the square root, if you can factor a perfect square out of that number, then you should do that, and then you should evaluate that perfect square. Okay. We don't want a radicand to be a fraction. In other words, we don't want any radicals in the denominator. All right, so we're going to rationalize the denominator, so we'll go through that as an example in a bit. It really helps if you know your perfect squares. So I would say this is the bare minimum that you should know. I would recommend you know up to 20 just to help yourself out with some of the bigger numbers. I would actually expect you to know 11 and 12 as well. And then 13 through 20, if you don't already know them, it's something that I would take a look at. It'll certainly help you out as you go through Algebra 2 next year. Okay, so simplifying just means that I'm going to find another way to write what I'm given, right? So I'm not going to evaluate. So in other words, in my first example, I'm not being asked to evaluate the square root of 3 over 49. Okay, I'm asking to rewrite this expression in another way, which we will call simplified. Okay. Now, following our rules, I don't want anything happening in the denominator. I don't want a fraction here, right? So if I were to rewrite this as the square root of 3 over the square root of 49, I do not want any square roots in the denominator. Right? But what I do know is that the square root of 49 is 7, right? 49 is a perfect square. So I could just rewrite this as the square root of 3 over 7. I can't do anything with the numerator, and so this is simplified form. This is my answer. Right, next example, square root of 72. Right? So what I'm looking for is the biggest square, the biggest perfect square that will fit within this number. That's going to be the quickest way to get through these. Alternatively, you could do your tree. So I could be like, okay, 72 is 2 and 36, 36 is 6 and 6, so I have a perfect square here. Right? But if you know that 72 has 36 in it, you can jump to the fact that 72 is the same thing as 2 times 36, okay? Which, I'm going to write this out, but you don't have to show all of this work, obviously. But that means that the square root of 2 times 36 is the same thing as the square root of 2 times the square root of 36, which is 6 root 2, right? So that's why we're allowed to do this, because I can actually split up the multiplication and then rewrite with my number there in front. Okay, example 3, now I'm multiplying two numbers together. So what I'm going to do is first simplify the square root of 32. Okay, so I can simplify the square root of 32 into 4 and 8, actually 16 and 2. So I can take a 16 out of this, right? So that would be 4 root 2. Right, now, when I multiply, you're going to multiply basically your like terms together. So I'm going to multiply the square roots together, so whatever's in the square root. And keep in mind what a square root is, right? So a square root is some number squared is equal to the radicand. So the square root of 2 times the square root of 2 should, by definition, be 2. Okay, or if you combine these, it would be 4 times the square root of 4, which is also 2. So 4 times 2 is, as we know, 8, so that's my final answer. Alright, next example, now I'm adding. Right, so when we're adding, we're going to treat this just like we would a variable. So if this was hypothetically x plus 3x, then this would be 4x. Right? So same thing here. I have the square root of 5 plus 3 times the square root of 5. So how many square root of 5s do I have? I have 4 square root of 5s. Right, so we're just combining that coefficient right there. That's what we're adding together. Alright, similar thing here, except I have to do a little bit of simplification first. So I have the square root of 8 here. Now I cannot subtract this the way that it is. The square root of 2 does not match with the square root of 8. So similar to my variables here, if I have, for instance, x minus y, you cannot simplify this, right? They're different. So I have to do a little bit of work to get the square root of 8 to match the square root of 2. So I will simplify, and I know that the square root of 8 simplifies to the square root of 4 times the square root of 2. So the square root of 4 is just 2, and I'm going to end up multiplying this by my outside scalar. So I end up with 4 root 2. Right, so this is my simplified version of 2 root 8. It's 4 root 2. Now I can combine. So I see that I have square root of 2, square root of 2. I have two like terms, so I can combine them, and I'm just going to subtract the coefficients, so this will be 3 root 2. Alright, this time both of these have to go through a little bit of simplification first. So I know that the square root of 48 is 16 times 3. I know that the square root of 27 is 9 times 3. Okay. So going through this, the square root of 16 is 4. And 4 times 9 is 36. The square root of 9 is 3. So 3 times 4 is 12. Now I can combine my terms. So I will get 48 root 3. Alright, let's move on. Okay, so now I have a bunch of things going on. Looks kind of confusing. So all we're going to do is simplify and hope that things work out. So I have 5 root 200. So it looks like the biggest square that will come out of this is 100. So I'm going to rewrite this as 5, the square root of 100 times 2, plus 3 root 2. This is already as simplified as it's going to get. Minus 5 times 72 is 36 times 2. Okay, so again, my 100 here is the same thing as 10. Sorry, the square root of 100 is the same thing as 10. So the square root of 100 times 5 is 5 times 10, or 50. Again, nothing we can do with that. And then the square root of 36 is 6. 6 times 5 is 30. Right, now I can combine my terms. So 50 plus 3 is 53. 53 minus 30 is 23. Root 2. Okay, now what if I cannot combine everything? Well, that's okay. Right, so here I have 90 square root of 90 plus square root of 50 minus square root of 640 plus square root of 18. This isn't going to end up working out so pretty. I'm going to end up with 2 terms at the end, but that's okay. So I'm just going to simplify what I can. Looks like I have the square root of 90 here, so that will take a 9. Right, so that's 9 times 10. 50 is 25 in it. 640 has a 64 in it, so that's 64 times 10. And then 18 also has a 9. Okay, so now I'm going to simplify this. So the square root of 9 is 3. The square root of 25 is 5. The square root of 64 is 8. And the square root of 9 is 3. Okay. Now I'm just going to combine what I can. So I'll combine my like terms at this point, which are going to be 3 root 10, negative 8 root 10, and then 5 root 2, and 3 root 2. So my final answer is going to be 3 minus 8, so negative 5, root 10, plus 5 plus 3 is 8, root 2. Alright, now they want us to rewrite 2 root 3 so that the denominator is a rational number. Okay, so this is called rationalizing the denominator. It makes sense because I'm making the denominator into a rational number. And what I'm going to do is multiply by a fancy version of 1. So this is very similar to the concept of getting a common denominator. What I need to do is multiply by whatever I have in the denominator. Right? So kind of the opposite, if you will. That will remove the square root. Right? So squaring something will remove the square root. So I'm going to multiply by a fancy version of 1. So I'm going to multiply by the square root of 3 over the square root of 3. And the reason why I would do this is because the square root of 3 times the square root of 3, as we talked about before, the square roots will cancel. I'm just left with 3. Right? Or in other words, the square root of 3 squared. So another way of thinking about this is the square root of 3 squared. Square and square root are opposites of one another. They will cancel, so I'm left with 3. Okay, so on the top I just have 2 root 3. There's nothing I can do to simplify this further, so this is my final answer. Right, very similar with my next example. So I have 4 root 2. I'm going to multiply by the square root of 2 over the square root of 2. On the top I will end up with 4 root 2. Things are happening. On the top I'll end up with 4 root 2. On the denominator, the square root of 2 times the square root of 2 is 2. I do see that I have something that can further reduce 4 and 2. So 4 divided by 2 is 2. So my final answer is 2 root 2. Right, so if you have something that can simplify further, then go ahead and do that. Alright, let's move on to example 11. Now I have square roots in the numerator and the denominator. So I'm okay with having a square root in the numerator. Right, that's fine. I just do not want square roots in the denominator. It's kind of like bad etiquette. So I'm not going to worry about this 7. I'm only going to worry about the square root of 5. Okay, so I will end up multiplying these. So the 3 is just, it's its own thing, but the square roots I can combine. So the square root of 7 times the square root of 5 is the square root of 35. And in the denominator, the square root of 5 times the square root of 5 is just 5. Okay, there's nothing that I can simplify out of this further, so this is my final answer. Alright, number 12 and example 10 are very similar. So here, if I multiply by the square root of 3 over the square root of 3, again, these will cancel out. On top, I have 12 root 3. On bottom, I have 3. 12 over 3 is 4. Alright, and moving on to 13. So 13 and 11 are similar. So I'm going to multiply by the denominator. So square root of 10, square root of 10. Okay, on top, I'm going to end up with 2. The square root of 3 times the square root of 10. Remember, you can combine these. Anything outside the square roots you combine. Anything inside the square roots you combine. Okay. 2 doesn't have anything else. So 2 just remains 2. The square roots will combine to make the square root of 30. And on the denominator, just 10. There's 2 over 10 here. That can reduce. So I will end up with the square root of 30 over 5. And that's it. Nothing else that I can do with that. Alright, moving on down to my last 2 examples. Okay, on 14, you have 2 options on how you can start this. You can reduce the square root of 8 right off the bat, or you can multiply and then reduce. So I'll multiply first. What the heck? Whatever you want to do. So I'm going to multiply by my denominator first, so it's root 3 over root 3, which ends up with 9 root 24 over 3. That's a really bad 24. Let's do that better. Okay, so 9 root 24 over 3. So I see that 9 and 3 can reduce. So 3 root 24, and 24 has a 4 in it. Right, so I can reduce this further. So the square root of 4 is 2. 2 times 3 is 6. So my final answer will be 6 root 6. And there's nothing that I can simplify further. Alright, my last example, I want to solve for x. It looks like I have vertical angles here, so my angle here x squared, and then my angle here 60. They should be equal. So that means I can set up the equation, x squared equals 60 degrees. In solving for x, I will square root both sides, meaning x is the square root of 60. And I can reduce this. 60 is 4 times 15. So x will be 2 root 15 degrees, and there's nothing else that I can simplify out of this. Alright, your homework is listed below here. We're just going to practice simplifying radicals. This is all in an effort to just get a little bit of review before we go into triangles, right? More on triangles, because we'll be using a lot of square roots in that unit. So go ahead and give this a shot. If you have any questions, let me know. Otherwise, have a fantastic rest of your day.